multispectral map paints this synthetic corn block amber and calls it stressed. It cannot say whether the cause is nitrogen deficiency, water stress, or early tar spot, so the alert is not yet something a sprayer can act on. SpectraRx is the analytics layer that reads the full hyperspectral curve. It does not own the satellite or sensor. One click runs the deterministic chain. Acquire a 424-band hyperspectral cube. Correct top of atmosphere radiance to BO a surface reflectance. Diagnose every pixel with a spectral CNN. Gate on confidence and physics agreement. Then prescribe and generate a record template. No language model is in the trust path. The amber blob resolves into typed zones. Amber is nitrogen deficiency. Blue is water stress. Red is early tar spot. Hatched pixels are abstained and routed to ground truth scouting. On this default calibrated scene, 1% of pixels abstain rather than being forced into a diagnosis. The same field, read by the Sentinel-2 broadband incumbent. It is a real baseline, not a strawman. On the held-out synthetic test set, its macro F1 is 0. 69, compared with 0. 887 for the 424-band spectral CNN. The abstention view. Hatched pixels are the cases the system did not diagnose because confidence is low, signatures are mixed, or the physics check disagrees with the classifier. That evidence routes to scouting. On this scene, the 1% abstention is visible rather than hidden behind an overconfident prescription. The credibility test is in the spectral inspector. It shows 1 pixel's calibrated reflectance across 424 bands, the shaded documented diagnostic feature, and an orange band saliency trace. The comparison lets an agronomist inspect whether a call has support at the expected wavelengths. Nitrogen deficiency. Its diagnostic evidence is in the 680 to 720 nanometer red edge, where the REIP shifts. Here the saliency trace can be compared with that documented diagnostic range, independently of the classifier's feature model. Water stress. The inspector shows the documented shortwave infrared water features, including the 970, 1450, and 1940 nanometer checks. They are diagnostic checks. This screen does not claim they are the CNN's highest saliency peaks. Early tar spot has its most useful saliency evidence in the sampled 530 and 535 nanometer bins, nearest the PRI diagnostic near 531 nanometers. That comparison is made independently of the classifier's feature model. It gives the viewer a concrete check on the model's evidence. Calibration is not cosmetic. On the held-out synthetic, physics-grounded test, skip atmospheric correction, feed raw top of atmosphere radiance to the classifier, and accuracy collapses from 0. 887 to 0. 373. Downstream confidence and physics agreement gates then send 92. 2% of seed 7 pixels to abstention. Correction back on restores BO a surface reflectance for this scene. The gates still expose low confidence or physics disagreement cases, but the calibrated diagnosis can move to the zone-level prescription rule. This is a different synthetic acquisition of the same field. The pipeline reruns from scratch, and the abstention rate changes with the scene rather than being printed as a fixed result. Capture C uses different noise and returns a different abstention rate. The number is measured per pixel for the scene on screen, not reused as a universal claim. Back to capture for the prescription. Per pixel diagnosis is aggregated from 5 meter pixels to 25 meter management cells with a 27 meter boom profile. This default scene has 144 cells, 21 apply, 25 scout, and 98 healthy. A zone at or above 34% abstained pixels becomes scout. Other zones use their non-abstained majority. Tar spot receives fungicide only inside the R3 window. The prescription exports as ISO-XML and GeoJSON, alongside the IPM record template. The scene is synthetic and physics-grounded. The export formats are real, but live sensor and farm management integrations are not implemented in this demo. Here is the EU Farm-to-Fork IPM-style record template, generated deterministically from the diagnosis and prescription. It includes zone coordinates, spectral evidence, alternatives evaluated, recommended product and rate, the R3 deadline, calibration provenance, and an agronomist sign-off line. It is a demo-generated template for agronomist and compliance review, not a live filing. Numbers need scope. This benchmark compares SpectraRx with Sentinel-2 on 280 held-out synthetic, physics-grounded pixels from an unseen cultivar and soil. Macro F1 is 0, 887 for the spectral CNN and 0, 69 for the broadband incumbent. It is a reproducible synthetic distribution shift result, not a real field guarantee. The gap is not uniform. Nitrogen is near 1, 0 for both models, so the broadband incumbent remains a strong baseline. On this held-out synthetic set, water is 0, 97 for SpectraRx against 0, 63 for Sentinel-2, and early tar spot is 0, 77 against 0, 61. These figures describe this test, not every field. Why held-out matters. The model trains on cultivars A and B, then tests on cultivar C with different soil. That is a synthetic distribution shift, designed to test generalization rather than memorization. The methodology and confusion matrix behind the score are on screen. Detection says something is wrong. SpectraRx diagnoses what and why, aggregates the result into a boom-aware prescription, and creates an IPM-style record template for review. A zone at or above 34% abstained pixels routes to scouting. Other zones use their non-abstained majority. Calibrated diagnosis, visible abstention, boom-aware prescription, and a reviewable IPM template. That is what Veripragna builds. See the full breakdown at veripragna.com/demos/hyperspectral agriculture AI, building true intelligence.